our topic for this video is all about determining polynomial equation given complex or imaginary roots. So, the learning target, after watching this video, I hope everybody can find the polynomial function or else equation given the zeros or roots. So, first of all, what are the steps in finding the polynomial equation or function? First, we have find the linear factor of each zero or root. Right after that, you multiply the linear factors. Okay, so for our first problem, find the polynomial equation whose roots are 4, 2 plus I, and 2 minus I. So, we are going to start with our first step, and that is list down the linear factors. So, the linear factors. So, I would like to recall shortly some of the concept that might be beneficial for you to understand how are we going to make it into linear factor once again. So, we all know that these roots are basically the values of x as well, right? X equals 4, so we do have x equals 2 plus I, and x equals 2 minus I. Now, our shortcut for this, for us to be able to make a linear factors out of this given roots, you just simply return it, the terms here at the right side of the equation, just return it here back together with our variable x, and of course the opposite sign of the given expression. So if it's positive 4, therefore we will have x minus 4. Okay, next, for this guys, for our complex zeros or imaginary zeros guys, I would like you to consider this as a representation of one number only, and thus if we're going to transpose this, we are supposed to consider this as a whole term. So if you're going to decide what would be the operation if I'm going to write here x, is it positive or negative? So here, looking at the sign of the first term of the given expression, it's positive 2. So that would be the basis, so you will have minus. And the rest of the term, copy the entire term, do not change anything there. So 2 plus I, and same goes with the second complex. So it follows. So before the given expression, the first term, the sign of the first term is positive. So therefore that will be your basis as well. So you will have x minus. Then copy the entire expression. And you're done with the factors. So these are the factors already. You may now proceed with multiplying the factors, but if it involves linear factors, somewhat like this, so you are supposed to multiply first those complex linear factors. So we are supposed to multiply the x minus 2 plus I with x minus 2 minus I. Okay, if you're going to observe our linear factors, it's quite complicated. How are we supposed to multiply this kind of linear factors? So I will just present to you some of the shortcut, and I look for some patterns for us to easily multiply this two. So we will relate this to some of the special products so that we can easily multiply this. But before we do that, we need to first regroup. So how are we going to regroup the given linear factors? So for us to regroup, let's just group x minus 2 together and just copy the I, and same goes with the second linear factor. So we will group x minus 2, then copy negative or minus I. That's it, we're done regrouping, and I'd like you to observe Can you see the pattern here? So if you can identify, look at here, x minus 2, it's a group already, plus I, and another group minus I. So as you can see, we do have this special pattern, which is a plus b, and then the other one, we have a minus b, wherein our x minus 2 is represented by a, and our I is represented by b. Same goes with the second linear factor, x minus 2 is represented by a, and I is represented by b. So now, I don't know if you can still remember how to multiply sum and difference of two terms. So the complete process for that is what we call the FOIL method, right? So we do have this FOIL method. So let's see. So let us set aside first our linear factors. Let's see the pattern first so that later on we can use the concept. So a plus b multiplied with a minus b. So using the FOIL method, a times a squared. A times negative b, negative ab. B plus b times a, so we will have positive ab, and positive b times negative b will have negative b squared. And as you can see, we do have here like term, so we have negative ab and positive ab, so we need to combine this like terms. So combining this, negative ab plus ab, so this will be equal to 0. Thus, simplify it more, we will have a squared then minus b squared. Therefore, we can use this pattern for us to easily multiply our sum and difference of two terms, which is also applicable here in what we have reviewed a while ago. Because as you can see, we regrouped it and we found out the pattern that is aligned with a plus b and a minus b. Therefore, we can multiply this quantity x minus 2 plus I with quantity x minus I by using this pattern, the a squared minus b squared. Therefore, we can simply square the first term or the letter a and square the second term or the letter b and proceed with difference. It is difference of two squares. That's it. So let's now multiply using the pattern that we recall. So it's a squared minus b squared. So I will now erase this one so that we can now multiply our complex linear factor. So maybe I can erase this one, the a minus b. I do hope you can still imagine the pattern. Okay, so now, as discovered out of the pattern a while ago, to multiply this, we can do the shortcut, which is a squared minus b squared. So what is our a here again? So it's x minus 2. We just simply multiply or square the x minus 2 squared and I squared, so that would be I squared and difference. So we do have x minus 2 squared minus I squared. So now let us evaluate this one, x minus 2 squared. So that is square of two terms, squaring binomial. So we will have x squared minus 4x plus 4. That this is the product if we're going to multiply x minus 2 with x minus 2 with itself. And of course we have here the simply copy the I squared. Now, I'd like you to remember this in all the cases. If you want to check this, if how it happened, so you just research on your own. So, but I just would like you to remember this, that any I squared is always equal to -1. So, for you to be able to simplify the given polynomial, your answer here, you need to evaluate by substituting the value or equivalent of I squared. So, continuing the process, so we will have x squared minus 4x plus 4 minus, and then you change the I squared into -1. So, again, in all the cases, if you see I squared, that is always equivalent to -1. And next to that is you are going to combine like terms or do the process there. As you can see, we do have positive 4 constant and -1 constant. So combining it more, so we will have x squared minus 4x plus 4 minus -1. So this will become, so applying the rules in integers, in subtracting integers, if we have 4 minus -1, so keep plus change, we will have this as positive. So x squared minus 4x plus 4 plus 1. So therefore, we can now have x squared minus 4x plus 5. This is the product of the two complex factors that we have. Okay, and next to that, we'll just simply multiply this x minus 4 to the given trinomial that we got a while ago. So multiplying these two, so we will have x cubed minus 8x squared plus 21x minus 20. Okay, that's it. But this is not yet the final answer, because based here in our problem, find a polynomial equation. Therefore, we need to express our final answer into a polynomial equation. How? By equating this polynomial to 0. And this is our final answer. And that's it. X cubed minus 8x squared plus 21x minus 20 equals 0. Okay, so next example. What if our problem is this one? Find the polynomial equation whose roots are positive and negative for I and I. So of course, we are going to start again with linear factors. So what will be our linear factors? Actually, it is quite easier compared to the first problem that we have earlier. So the linear factors, so for this, positive and negative for I, it is just x plus 4i and then x minus 4i. As simple as that. And then for positive 1, of course, we have x minus 1. Okay, so same process as I told you a while ago. For us to find the polynomial of this given roots, particularly if we have complex roots, so we need to get the linear factors, and right after that we need to multiply first those complex factors that we have. So x plus 4i and x minus 4i, this is what we are supposed to multiply first, so I'll just simply copy the x minus 1 first. So how are we going to multiply this? This is very simple. The usual way of multiplying the binomial with binomial. So just do the FOIL method. But as you can see, this also follows the product of sum and difference of two terms. As you can see, we have x plus 4i and x minus 4i. So that means we can also apply the one that we recalled a while ago, which is the a squared minus b squared, the shortcut. We just simply multiply the first terms and last terms. So x times x, we will have x squared. And positive 4i times negative 4i, we will have negative 16i squared. That's it. But as you can see, we still have I squared here. So we need to simplify this. We need to evaluate. So we will have x squared minus 16. And we need to change the I squared. So I squared is always equivalent to what? So we have negative 1. Always, right? So now we'll just continue our process evaluating this one. We will have x squared. So negative 16 times negative 1 is positive 16. Set and copy the next linear vector. And we can now multiply this two. We do have x squared times x. We will have x cubed. X squared times negative 1, negative x squared. Positive 16 times x, positive 16x, positive 16 times negative 1, negative 16. As you can see, this is already arranged in decreasing order, but this is not yet the final answer because as per our problem, it should be polynomial equation. Therefore, we need to rewrite this into an equation. X cubed minus x squared plus 16x minus 16 equals 0. Okay, and thus, this will be our final answer. So, as simple as this one. Okay, so we have x cubed minus x squared plus 16x minus 16 equals 0. Okay, so that's it for this video. I hope you learned about finding or determining the polynomial function or else equation given complex or imaginary roots over zeros. So again, don't forget to subscribe so that you will be updated of our playback